Strategic maintenance planning. It involving the selection of maintenance strategies from among alternative courses of action for the enterprise as a whole. It is about deciding in advance what maintenance types to use to manage the various operating risks of the organization. This is what the maintenance manager is responsible to do. Operational maintenance planning. It is the process of establishing the sequence and relationship among task elements and providing the parts and resources needed to deliver the work plan. Scheduling is the process of determining which jobs get worked on, when and by whom, based on the priority, the resources, and asset availability. The scheduling process should take place before the job is executed. Work execution and completion. Work execution ensures adherence to quality, safety, and precision. Work completion involves detailed documentation. Work. Reports, FILU. Reanalysis, asset history. Definition. Planning is the fundamental management function which involves deciding beforehand what is to be done, when is it to be done, how it is to be done, and who is going to do it. It is an intellectual process which lays down an organization's objectives and develops various courses of action by which the organization can achieve those objectives. It chalks out exactly how to attain a specific goal. Planning is nothing but thinking before the action takes place. It helps us to take a peep into the future and decide in advance the way to deal with the situations which we are going to encounter in future. It involves logical thinking and rational decision-making. Let's explore what are planning characteristics and hinders to planning. Managerial function. Planning is a first and foremost managerial function provides the base for other functions of the management, i.e. organizing, staffing, directing, and controlling, as they are performed within the periphery of the plans made. Goal-oriented. It focuses on defining the goals of the organization, identifying alternative courses of action, and deciding the appropriate action plan, which is to be undertaken for reaching the goals. Pervasive. It is pervasive in the sense that it is present in all the segments and is required at all the levels of the organization, although the scope of planning varies at different levels and departments. Continuous process. Plans are made for a specific term, say for a month, quarter, year, and so on. Once that period is over, new plans are drawn, considering the organization's present and future requirements and conditions. Therefore, it is an ongoing process as the plans are framed, executed, and followed by another plan. Intellectual process. It is a mental exercise as it involves the application of mind to think, forecast, imagine intelligently, and innovate, etc. Futuristic. In the process of planning, we take a sneak peek of the future. It encompasses looking into the future to analyze and predict it so that the organization can face future challenges effectively. Decision-making. Decisions are made regarding the choice of alternative courses of action that can be undertaken to reach the goal. The alternative chosen should be best among all, with the least number of the negative and highest number of positive outcomes. Let's see what is planning process. Define the problem or opportunity. Identify the current situation, the desired future state, and the gap between them. Analyze the situation. Gather relevant data and information. Identify the root causes of the problem and assess the strengths, weaknesses, opportunities, and threats, SWOT, of the situation. Generate alternatives. Brainstorm possible solutions or courses of action and evaluate their feasibility, effectiveness, and potential impacts. Select the best alternative. Compare and rank the alternatives based on criteria such as cost, benefit, risk, and alignment with the goal or vision. Implement the plan. Develop a detailed action plan with specific tasks, responsibilities, resources, timelines, and milestones. Execute the plan and monitor its progress and performance. Evaluate the results. Measure the outcomes and impacts of the plan against the predefined criteria and indicators. Identify any deviations or problems and take corrective actions if needed. Review and document the lessons learned and best practices for future reference. Benefits of planning. Planning helps you clarify your vision and purpose. By setting specific, measurable, achievable, relevant, and time-bound, SMART objectives, you can focus on what matters most and align your actions with your values. Planning helps you manage your time and resources efficiently. By breaking down your tasks into smaller steps and prioritizing them, you can avoid procrastination and waste. You can also allocate your budget, materials, and human resources accordingly. Planning helps you anticipate and mitigate risks. By identifying potential challenges and opportunities, you can prepare contingency plans and backup solutions. You can also monitor your progress and adjust your plan as needed. Planning helps you communicate and collaborate effectively. By sharing your plan with others, you can get feedback, support, and buy-in from your stakeholders. You can also delegate tasks and coordinate with your team members to achieve synergy. Planning helps you improve your performance and quality. By setting standards and criteria for your outcomes, you can evaluate your results and learn from your mistakes. You can also celebrate your achievements and reward yourself and others for their efforts. Planning helps you reduce stress and increase satisfaction. By having a clear plan, you can reduce uncertainty and anxiety. You can also enjoy the process of planning and executing your plan, as well as the sense of accomplishment when you reach your goals. Planning helps you grow and develop personally and professionally. By planning, you can challenge yourself to stretch beyond your comfort zone and acquire new skills and knowledge. You can also reflect on your experiences and apply your learning to future situations. Dynamic and complex environments, changes in any of the elements of an organization's task or general environments can radically alter the plans and obstruct the entire planning process. Incidentally, this also main reason to do planning. Reluctance to establish goals. Reluctance on the part of some managers to establish goals for themselves and their units due to lack of confidence or fear or failure. Lack of planning skills. Planning is not a natural tendency for most of the persons, especially in current complex environment. Lack of understanding of planning frameworks, tools, and methods also leads to poor attitude toward planning. Lack of an appropriate planning climate. The lack of an appropriate planning climate within the organization as a whole. There may be lack of top management support. The manager's superiors may, for instance, be perceived as being uncommitted or even hostile to planning and to the use of objectives. Procedural inflexibility, which can weaken the effectiveness of planning, and continued pressure on line managers to act quickly, so there is not sufficient time to prepare effective plans, may create severe problems for those who have to forecast and act according. Let's know what is strategic maintenance planning. Elements of strategic maintenance planning. Strategic maintenance planning process. Strategic maintenance planning deliverable. Strategic maintenance planning team. Maintenance alignment with organizational objectives. Organization objective. Profit maximization. Market share growth. Customer satisfaction. Innovation and growth. Social responsibility and sustainability. Organization objectives serve driver for asset management objectives like equipment reliability, risk reduction, defect elimination, least operating cost, maximum production, failure avoidance. The asset management objective guides the tactical and operational actions at shop floor level as below. Asset management tasks. Breakdown maintenance, corrective maintenance, preventive maintenance, predictive maintenance, proactive maintenance, spare parts management, maintenance budgeting, manpower budgeting and skilling, asset management knowledge creation and management. Element of strategic maintenance planning. S&P carried out to achieve median and long-term objective of organizations. The strength of S&P shall match level of risk of equipment failure. S&P are guided by organization asset policy stated, implied, may be conflicting, exercise. What is your plan's asset policy? The S&P shall abide by financial constraint but make a case of cost optimization. The organization shall have consistent risk evolution methodologies and mitigation approaches. S&P should be documented at a level that is appropriate to the organization and the degree of sophistication in its asset management approach, reducing downtime and operational costs by preventing breakdowns and failures, improving safety and quality by ensuring compliance with standards and regulations, enhancing customer satisfaction and loyalty by delivering consistent and reliable service, increasing asset life cycle and value by preserving and improving their condition, supporting strategic goals and objectives by aligning maintenance activities with organizational vision and mission. Strategic maintenance planning process. Prepare a list of asset systems and their constituent assets and gather information about them. Identify risks. Create a table of potential events and their impacts, and includes risks to the delivery of the organizational objectives. Identify risk controls that exist. Analyze risks using appropriate process. Evaluate the level of risk. Estimate the likelihood and consequences for each potential event. Evaluate the level of risk over time. Where appropriate, establish whether the identified risks will change over time and how this will affect their consequences. Evaluate the tolerability of the risks, if any, are sufficient to keep the risks under control and to meet any legal, statutory, and other asset management requirements. Strategic maintenance planning deliverable. Maintenance objectives. The desired outcomes and benefits of maintenance activities, such as improving reliability, availability, safety, performance, and compliance. Maintenance scope. The identification and classification of the assets that are subject to maintenance, as well as the criteria and methods for prioritizing and selecting them. Maintenance approach. The definition and description of the maintenance tactics, techniques, and tools that are applied to the assets, such as preventive, predictive, corrective, or condition-based maintenance. Maintenance resources. The estimation and allocation of the human, financial, and material resources that are required to execute the maintenance activities, as well as the roles and responsibilities of the maintenance personnel and stakeholders. Maintenance performance. The establishment and measurement of the key performance indicators, KPIs, that are used to monitor and evaluate the effectiveness and efficiency of the maintenance activities, as well as the identification and management of the risks and opportunities associated with them. Maintenance improvement. The identification and implementation of the improvement actions that are aimed at enhancing the maintenance processes, practices, and outcomes, as well as the review and update of the SMP based on feedback and lessons learned. Maintenance operational planning. Simply planning. Planning characteristics. Planning for breakdown, preventive, and proactive maintenance. Planner competencies. How to write a good plan. The process of job planning encompasses verification of all aspects of the job to be done, as well as identification of the various input resources required to complete each job in an orderly manner. Planning is the process of determining the resources and method needed to perform maintenance work efficiently and effectively. Planning defines what and how. Planner develops a work plan to repair or perform a CM or PM for asset. The plan include work description, task, sequence, material, and tool requirement, work crew skill set, and safety requirement. A work plan is the key deliverable of the planning process. This area is where the most gains in productivity can be made. Every hour invested in planning saves 1 to 3 hours in work execution. More wrench time. By planning ahead, maintenance workers can spend more time on actual repairs and less time on waiting for parts, tools, permits, or instructions. Work completion within estimates. By having a clear plan and scope of work, maintenance workers can avoid delays, rework, or scope creep that can increase the cost and time of the project. Higher quality and reliability. By following a standardized and documented procedure, maintenance workers can ensure that the work is done correctly and consistently, reducing the risk of errors or failures. Improved safety and compliance. By adhering to the best practices and regulations, maintenance workers can prevent accidents, injuries, or violations that can harm themselves, the equipment, or the environment. Maintenance work pack. Job plan, the workflow process diagram of job in line of sight detail. Skills/competencies required, the expertise and competencies needed to do the job correctly. Job procedure, task by task, fully detailed description with quality standards and corrective. All drawings relevant to the could be mechanical, electrical, civil, structural, process diagrams, etc. Bill materials for the job, the used in the job including part number, part, and quantity required. Tools list for the job, the tools needed to do the job safely and correctly. Equipment list for the job, include the equipment specification e.g. Frana Crane 20T, mobile air compressor CFM, elevated work platform, etc. Settings/set points for calibration and adjustment. Inspection and test plan with quality standards, pass or fail criteria for each task. Includes providing tolerances and condition criteria to confirm a part can remain in service or is to be replaced. Data sheets of the equipment, information on the design and service specifications. Record sheets, a place to make a record, often observation or measurement as proof. Often satisfied with an inspection and test plan. Calculation sheets, a place to do the calculation laid out in the sequence of the calculation with space for figures and of a correct calculation. All permits and tags, safety, environmental, disposal, transport heritage, plant handover, etc. approvals. Risk assessment forms, site risk assessment and management documents. All technical tables, copies of manufacturer data tables or international engineering tables highlighted 10 show the information applying to the job. Special requirements, instructions and particulars specific to the job that must be observed. Commissioning plan, control testing to confirm proper operation. Parts and materials. All parts and materials are identified and gathered together in one location. Proof test recording sheet, a check sheet to note the proof test results for each job plan activity that confirms work quality is achieved. Failure mode and equipment health report, a record of the technician's observations and decisions and photographic evidence of failure modes. Symptoms of ineffective planning. Maintenance people standing around waiting on parts. High rework. Poor work performance. High stockout in the storeroom. Planners being used to expedite parts. Maintenance personnel arriving at the job site and waiting for the asset/system to be shut down. Wait is over 15 minutes. Frequent trips to storeroom by maintenance personnel. Production downtime always more than. Planning for breakdown maintenance. Ensure adequate craftsmen with required skill sets shall be available at shift considering people on leave, training and SPL duties. Ensure availability and quick retrievability of special tools and provisions. Ensure availability and quick retrievability of machine manuals, drawings, and standards as required. Machine history shall be reviewed to check breakdown and preventive maintenance activities carried out on equipment. Also, if any other corrective order is pending against /PM schedule is approaching. If subject breakdown is repetitive in nature as informed by planner or otherwise, due diligence approach shall be carried out. Experienced engineer or supervisor must attend the breakdown at the earliest and set the line of diagnosis. Craftsmen shall be trained for multi-skilling to possible extent. A small stock of consumable and C-class material shall be kept at maintenance department. Mini store can be utilized for breakdown maintenance. To the extent possible, ready assemblies shall be kept for machines and shall use during breakdown rectification. Faulty assembly can be corrected afterward. Availability of common stock for replacement or diagnosis purpose shall be available at store and can be withdrawn with minimum efforts. It is to be ensured that craftsmen shall carry all required tool to equipment under breakdown, and they have provision to carry all at a time. Supervisor/shift in charge must take electrical isolation and other safety precautions. A copy of machine panel drawings, a set of fuse, relays, and similar other provision can be kept in panel for quick diagnosis. Tradesmen shall be trained for best approach to diagnosis common problems. A machine operator with fair knowledge of equipment mechanisms can be serve as good resource for fault diagnosis. Maintainers shall share knowledge with operators. Work order shall be closed with all required details, and maintainer or operator must provide feedback for quicker resolution or a lesson learned. All efforts shall be made to capture work order information and feedback in CMMS or otherwise computerized sheet. A trigger for YY analysis shall be embedded in work requests/work order closer, e.g. breakdown, X hours or repeat breakdown. Planning for preventive and predictive maintenance. Details task list shall be made with special emphasis on test method or measurement to check job done as per standards. Critical measurement/inspection shall be supervised by engineer or designated person and must be signed. Wherever warranted, photos shall be taken or values to be noted down. Individual or group task time estimation with plus 15% range. Determine number of craftsmen and their respective skills. Determine if special tools, provisions, lifting, shifting arrangement required. All relevant SOPs, manuals, drawings, and report from previous preventive maintenance shall be kept ready for ready reference. Line up with external service provider with clear scope of work, as required. Machine history shall be reviewed to check breakdown and preventive maintenance activities carried out earlier and if any work order is pending. If subject equipment indicate any repetitive breakdown, due diligence inspection or test shall be planned with preventive task list. Ensure replaceable spares, consumable availability, and reserve them for subject plan. List of work permit, LODO shall be part of work pack. For predictive maintenance, vibration pickup points shall be clearly indicated on data capturing sheet. Planning for proactive maintenance. Proactive maintenance task as generated as the result of RCA, CAPA, and CBM risk-based inspection, or design-out activities. Its predominantly include new design, material selections, procurement of spares, hiring services of external expertise, assemblies, and trials. Due diligence shall be paid at each step. Once all prerequisites are ready and verified for, as per design and quality attributes, further process shall be developed for its execution. Proactive maintenance jobs are, as on of their own kind, all care must be taken, so not to miss any step or critical inspections/observation. Planner must take help of supervisor or senior craftsman while preparing such procedures. Individual or group task time estimation with plus 15% range. Determine number of craftsmen and their respective skills. Determine if special tools, provisions, lifting, shifting arrangement required. All relevant SOPs, manuals, drawings, and report from previous preventive maintenance shall be kept ready for ready reference. Line up with external service provider with clear scope of work, if required. Machine history shall be reviewed to check breakdown and preventive maintenance activities carried out on equipment, also if any other corrective order is pending against/PM schedule is approaching. If subject equipment indicate any repetitive breakdown in nature as informed by planner or otherwise, due diligence inspection or test shall be planned with preventive task list. Ensure replaceable spares, consumable availability, and reserve them for subject plan. List of work permit, LODO putting required signage, and informing operators of nearby equipment shall be part of work pack. Core competencies required for planner's work. Fully certified to perform relevant maintenance activities, e.g. applicable licenses, permits, and qualifications. Sound and correct understanding of equipment reliability concepts. Solid appreciation of risk management strategy and practices related to plant and equipment. Solid appreciation of quality management methods and practices related to plant and equipment. Planning capabilities can be enhanced by ensuring the following: employee involvement and roles. Educate all maintenance stakeholders from a plant manager to the maintenance technician in P&S process to ensure all players understand their role. It is recommended that a senior maintenance technician may be assigned to the maintenance planners for few hours a day. Planning support job is a good practice. Maintenance planners must have a library of information including equipment manuals, drawings, specifications, and specific equipment manufacturers' libraries. Planners shouldn't perform additional duties such as temporary or relief supervisors, safety, or environmental representative. The planner is not a secretary or clerk. Planners shouldn't expedite parts for breakdowns or problems. Their responsibility is to ensure that future work is planned properly so it can be executed effectively. Planned work package should be reviewed by a craft supervisor to validate that the work package is doable as planned before scheduling. How to write maintenance task description. The planner shall visit the facility/equipment where work is to be planned. Outline the task to done and list out provisions to be required for work completion wherever warranted. Shall take help from senior craftsman or supervisor. Use template to articulate the safety requirements, job sequence, job details, spare part requirements, estimated times, craft trade-wise man-hours required, drive material and manpower cost as required. All efforts shall be made to provide methods of proof test against each task undertaken wherever applicable. Standards shall be provided with task list. To possible extend these task lists shall made modular and indexed for easy retrieval and reuse. For repetitive task, preventive maintenance, feedback from previous works shall be suitably added to task list. Effectiveness of these plans shall be checked during work executions and work completion. Contingency planning and mitigation. Reevaluate situations and preparedness. Contingency characteristics. Contingency mitigation. Contingency identifications. Contingency planning. Contingency plan is a plan of action for a facility. It is intended to be used following a forced outage when a natural disaster, primary utility/services failure, or critical/key equipment failure causes an unplanned loss of production. Generally, these are of cases of too low probability and very high impact. A well-written equipment breakdown contingency plan will provide a planned response to recover from events that result in a forced outage which impacts production and facility equipment. Identification project can be allocated to engineers for initial workout and afterward can be refined by team of experts. Examples: underground HT/LT cable failures, failure of bottleneck process, non-availability of electrical supply from utility provider. List all critical utility and plant essential services. List every critical object in each department. For each key/critical equipment and service, try to determine what events, problems, or trends could potentially come up. Departmental team shall determine the process or business impact in case a negative event, problem, or occurrence takes place. These departmental-level contingencies shall be assembled in plant-wide contingency list. It shall also check for business impact if some of these contingencies falls simultaneously. A central team shall evaluate each contingency and quantify the risk as per predetermined methods or procedure. A list of contingency with prioritization shall be worked out for mitigation planning. Contingency mitigation process. Identify preventive controls. Measures taken to reduce the effects of equipment or service disruptions can increase system availability and reduce contingency life cycle costs. Create contingency strategies. Thorough recovery strategies ensure that production may be re-established quickly and effectively following a disruption. The contingency plan should contain detailed and specific guidance and procedures for efficiently repairing or replacing damaged equipment or restoring services. Contingency plans shall estimate the resource requirements and base calculations for management approval. The contingency plan should be a living document that is reviewed regularly and updated as required to remain current with equipment enhancements and organizational changes. Example of external agencies required: water, natural gas, or other fuel source utility suppliers, critical equipment repair firms/contractors/server support. Example of external agencies required: original equipment suppliers, rental equipment sources. Material planning and maintenance, spare optimizations. Inventory policies of organization. Inventory classifications methods. Risk, cost benefit for purchase decision. Standardization of spares. Inventory management policies of organization. A clear maintenance inventory policies and thereof approval procedures and authorities shall be defined. The policy shall consider organization short-term and long-term objective, aging of subject assets, nature of production process, predominant mode of maintenance or maintenance strategies, maintenance budgets, inventory management policies of organization, inventory management policies of organization, a clear maintenance inventory policies and thereof approval procedures and authorities shall be defined. The policy shall consider organization short-term and long-term objective, aging of subject assets, nature of production process, predominant mode of maintenance or maintenance strategies, maintenance budgets, inventory classification, ABC analysis, usage value, consumption X price per unit, HML analysis, high, medium, low unit price, VED analysis, vital, essential, desirable, criticality of the item, SD analysis, scarce, difficulties, easy, procurement difficulties, Gulf analysis, government, ordinary, local, foreign source of procurement, SOS analysis, seasonal, off-seasonal, FSN analysis, fast, slow, non-moving material consumption, XYZ analysis, total inventory investment, risk, cost-benefit analysis for inventory decision, RCM analysis, FMEA analysis, lead spare policy FMEA sheet. BORM analysis, individual component or component class shall be reviewed for failure mode frequencies, its vulnerability to production process. Hyperlink Excel sheet. Past consumption data normalized to current production scenario. Maintenance material budgets will also helpful for inventory decisions. Keep strong methods to capture day-to-day data, their attention, and to act upon. Standardization of spares. Benefits of standardization. Leverage purchasing power. Buyers benefit from suppliers' economies of scale as they have the purchasing leverage to order bulk quantities of standardized spares and to obtain just-in-time support from suppliers. Holding fewer inventories. Part standardization offers reduced inventory levels because buyers can obtain the standardized parts directly from suppliers as they are identified and already listed across supplier websites/catalogs. Cost reduction. Buyers can arrange for a spontaneous resupply of parts and materials from their suppliers whenever equipment downtime occurs, which results in cost reduction. Less mistakes while processing orders. Reduces events of stockouts. Better know-how of standard spare. Comparison to multiple variant. How to standardize spare. New equipment orders shall include brand and model of common components, say electricals, hydraulic, rubber items, flexible piping, electronics cards, PLC, ECT. On quarterly basis, target shall be set to modified few machines to adapt common spares. Staff and craftsman upskilling planning. Maintenance task skills requirements. Evaluate individuals for skill set. Articulate skill gaps and training need identification, TNI. Plan trainings, evaluate impact, and reinforcement trainings. Skill evaluation process for maintenance team. List out major skills and competency required to do routine maintenance works, preventive maintenance works, major repair works, and machine fault diagnostics. Craftsmen shall be evaluated for degree of knowledge they have for a particular skill and accordingly classified to, say, hydraulics, PLC controls. The skill gaps shall be identified as part of TNI training need identifications. Monthly or quarterly classroom/on-job training, OJT, based training programs shall be conducted to upgrade individual skills. Craftsmen shall be examined for theoretical and practical knowledge. As required, reinforcement training shall be provided. Skill. Know how to solve a problem. Competency along with know how of problem solving the doer must able to apply in real-world situations. Knowledge body required for equipment maintenance team. Craftsman. Bearing maintenance. Bearing fitment and removal practice. Right lubrication practices. Mechanical drive maintenance. Hydraulic diagnosis and maintenance. Pneumatic controls. Assembly/disassembly procedures. Leveling and alignment of machines. Servicing/cleaning of static equipment. Engineers and supervisor. Design consideration of equipment. Work standards and precision maintenance. Mechanical fits and tolerance. Root cause analysis. Reliability engineering. Elements of maintenance planning and scheduling. Maintenance management system. Understanding of lead and lag KPIs and maintenance data analysis. Maintenance managers. Asset management frameworks. Evaluate risk out of various scenarios and setting the acceptable level of risk. Aligning maintenance strategy with production requirements. Optimum maintenance strategy for equipment. Design machine modifications. Managing asset life cycles. Maintenance work scheduling. Scheduling characteristics. Backlog management. Work prioritization. Scheduling methods. Manage work quality and completion feedback. Scheduling characteristics. Scheduling is a joint maintenance and operations activity in which maintenance agrees to make resources available at a specific time when the asset can be also made available by the operations. Scheduling ensures that resources, personnel, material, and the asset on which the job is to be performed will be available for maintenance at a specified time and place. The scheduling is a tool for lining up jobs waiting to be performed so that operations are best served while maintenance also makes optimal use of its resources. Production and maintenance coordination maximizes the use of windows of opportunity to accomplish work whenever and wherever equipment is not in use. In selecting jobs for the weekly master schedule, it must first be ensured that all preventive and predictive routines are scheduled at their predetermined frequencies. Any jobs that cannot be scheduled to meet those dates should be discussed with the requester in the context of other job priorities established by all attendees. Conflicts between internal customers must be resolved by their common manager in the optimal interest of the overall operation. Scheduling principles. Doc Palmer, a noted authority in the area of maintenance planning and scheduling, cites 6 basic scheduling principles. Job plans shall provide necessary skills and respective man-hours for a task for effective scheduling. Weekly and daily schedules must be adhered to as closely as possible. Proper priorities must be placed on new work orders to prevent undue interruption of these. Scheduler develops a 1-week schedule for each crew based on craft hours available, forecast that shows highest skill available, job priorities, and information from the job plans. The 1-week schedule assigns work for every available work hour. The schedule allows for emergencies and high priority, reactive jobs by scheduling a significant amount of work on easily interrupted tasks. Preference is given to completing higher priority work by underutilizing available skill levels over completing. The 1-week schedule assigns work for every available work hour. The schedule allows for emergencies and high priority, reactive jobs by scheduling a significant amount of work on easily interrupted tasks. Preference is given to completing higher priority work by underutilizing available skill levels over completing lower priority work. Lower priority work. Schedules. Crew supervisor develops a daily schedule 1 day in advance using current job progress, the 1-week schedule, and new high priority, reactive jobs as a guide. Wrench time is the primary measure of workforce efficiency and of planning and scheduling effectiveness. Schedule compliance is the measure of adherence to the 1-week schedule and its effectiveness. Scheduling scope. Bringing together in precise timing the 6 elements of a successful maintenance job: labor, tools, materials, parts and supplies, information, engineering data and reference drawings, custody of the unit being serviced, and the authorizations, permits, and statutory permissions. Matching next week's demand for service with resources available after accounting for all categories of leave, training, standing meetings, and indirect commitments, plus consideration of individual skills. Preparation of a weekly schedule that represents the agreed upon expectation regarding planned work orders to be accomplished with available resources. The schedule also assures that all preventive and predictive routines will be accomplished within established time limits. Consideration of alternative assignment strategies where the schedule assigns specific jobs to specific people, allowing second-string players into the game to gain experience, as feasible. Ensuring that responsible supervisors receive and understand the planned job packages for scheduled jobs. Managing work quality. Make a common briefing before start of the work about safety precautions, work precautions, and critical activities of the work. Follow all the tasks as per task list. Any task inapplicability or inability must be clarified with planner/HOD. Note down observations and confirm the proof test has been done. Collect values/photos/sketches. As required by task document, inspection of critical work shall be done by designated authority. Do not hesitate to consult manual/diagram/expert whenever in doubt. Maintained general housekeeping and work organized, assemblies, spares component must be kept in way not mixed with similar assembly. The likely human error must be kept in mind and shall cross-checked/supervised for same. During machine trials, function observations must be correlated/analyzed with inspections observation, and if required, new task can be created. Backlog jobs/work order management. Lead time work to be done must be identified as far in advance as possible so that the work backlog is known and jobs can be planned effectively and completely prior to scheduling. Accurate evaluations should be made of the priority of each job, given the perspective of the overall operation. Each job in backlog must be force-ranked so that the most important jobs are always scheduled and, where possible, executed first. Backlogs must be kept within a reasonable range. Backlogs below minimum do not provide enough volume of work to ensure smooth scheduling and effective utilization of all resources. Backlogs above maximum turn so slowly that it is impossible to meet customer needs on a timely basis. Consequently, they lose faith in the proactive approach and slip back into the reactive mode. Special or heavy demands resulting in excessive backlog cannot be scheduled unless additional resources are authorized or expected completion dates are relaxed. Effective feedback and documentation. Completion. All required information as per task list must be submitted in clear terms. All proof test and final handing over trials values/observation shall be provided. Care shall be taken to record all observations as job progress and shall submitted with work orders. Status/photographs/sketches shall be provided to clarify the observations. Any delay on account of planning shortcoming, material availability, and similar incidents shall be provided. Lesson learned or deviations, cost, labor utilizations, delay diagnostics, if happened, shall be highlighted to take care in future work. Alignment of planning and scheduling processes. Planning shall be relevant and realistic, so can be done efficiently and effectively. The planner shall survey the site physically and make task accordingly. Planner shall accommodate previous relevant feedback and suggestion in work procedure. Planner shall join scheduling meeting for major works apart from provided detailed task pack. Maintenance supervisor shall provide all details as per work order closer format and other feedback. Maintenance senior craftsman shall assist planner in developing the maintenance plan, as many craftsmen shall be utilized to help planner, so in turn they will also learn planning methods. Planning activities and work feedback requirement must be made clear to all maintenance levels and shall be complied of. Planner shall not be involved in day-to-day maintenance operation and always planned for next week. Planning and scheduler must analyze maintenance delivery performance and work out to improve the same. Planning and scheduling matrices. Percentage of planned work. This measure is the percentage of all scheduled jobs that have been planned. It assumes that all parts, procedures, specifications, tools, drawings, etc. have been identified before the job is scheduled. The benchmark is 90%. Percentage of schedule compliance. This measure is the percentage of work accomplished that is agreed upon or on the weekly schedule. Percentage of time that kits, materials, and parts are delivered on time. This measure is calculated as the number of times the kits, material, and parts were delivered on time divided by the total number of kits delivered. This percentage affects the planner's ability to plan jobs properly. Expediting parts adds unnecessary and wasteful cost to the P&S process. Percentage of time the right part S is delivered. As part of the planning process, planners and schedulers should have the confidence that a specific vendor will deliver the right part when required. Otherwise, this problem could create a delay in performing the work. The benchmark is 99% or higher. Percentage of work from a formal work PM/CBM. Most work should come from identifying the degradation of a component or asset far enough in advance of any PM/CBM tasks that the job can be planned and scheduled properly, thus minimizing unexpected delays and production loss. Percent rework. This measure is the percent of work orders requiring rework. Each organization needs to define what rework means to them. It may differ from one to another organization. The benchmark number is less than 2%.